All right, well, this is our unit on factoring, and there's only a few chapters in here, but it's actually a pretty dense lesson. And what's important to note is that if you can understand this, you're going to be in really good footing moving forward. If you don't understand how to factor something, then there's like, I don't know, 3 or 4 units after this where you have to do a ton of factoring. And so this sets the groundwork for the whole course of Math 11. Now, before we get into factoring a trinomial, that's what we're going to be doing. We're going to take a step back and just remember how to common factor something, which I think we've done before, maybe in grade 10. I can't remember. But I'll just show you kind of an example. I've got this over here, 12x plus 6. Let's pick a different one. How about 25x plus 5? And if I asked you to factor that, that means I'm asking you to divide something out. And often we try to divide the biggest thing. And so in this case, I could say, well, these can all be divided by 5. I can take a 5 out of both of those. So I can take the 5 out, or I can divide it out and turn it to a multiply here. But I have to reduce this. 25 divided by 5 is 5. There's an x remaining. And 5 over 5 is 1. So I've taken something that is predominantly adding, and I've turned it to something that is now multiplying. So factoring means turn it to something that's multiplying. And you could always check. I'm telling you these two are the same thing, but you can check to see if you factored right, because you can multiply this 5 back in. You can FOIL, kind of like grade 9 and 10. 5 times 5 is 25x. 5 times 1 is 5. And sure enough, that matches that. So you can always double check your factoring by just multiplying. So we're going to do example 1. Just wants you to common factor. Take something out. So I know I can divide by 2, but I think I can divide by 4. And they each have, can I divide by 8? No. They each have an x, so I can take out an x. That's the biggest thing I can take out. I can take out a 4 out of both of them, and I can take out an x out of both of them. So I take a 4x out, and then 8 over 4 is 2. X squared over x is just an x. 20 over 4 is 5, and x over x cancels out. So those are gone, those x's, and one of these x's is gone with that. And so this is now considered factored. If your very first term is negative, the convention is that you would take out the negative. So I'm going to divide what number, because these can both be divided by 2, but I can actually divide by 4. But because the first term here is negative, I'm going to divide by negative 4. And you'll see why in a moment. Do they both have at least an x? Yep, I can take out an x. And I can take out a y. I can't take out y squared. It would work for that one, but it wouldn't work for this one. So I have to just do that. So I have a negative 4xy. And then negative 16 divided by negative 4 is 4. X over x are gone. Y squared over y is just a y. 12 divided by negative 4 is negative 3. X squared divided by x, that leaves me just an x. And y over y, those will cancel. And what you have left with is the very first term here is positive, and for some reason we like that. So that's why if ever there's a negative out in front, divide by the negative, and that leaves your first term of whatever's left a positive number. Now, this is considered factored. Let's try this. Okay, the first term is negative, so I'm going to make sure to divide by a negative. They can both be divided by a 3. This has x2 and x3, so the biggest is the biggest. So they look for the smallest, but the biggest thing you can take out of each, like you can take out an x out of each. You can take an x squared out of each, but you can't take an x cubed out of this one. So the biggest we can take out is an x squared out of both of them, and the biggest we can take out is a y squared out of both of them. So I take out a negative 3, x squared, y squared. I take that out, I divide it out, and I'm left with negative 3 over negative 3 is 1. X squared over x squared is 1. Gone. Y squared over y squared. Gone. So I'm just left with a 1. Negative 9 divided by negative 3 is a positive 3. x3 over x2 is just an x, and y3 over y2 leaves me with just a y. And so this is now considered factored. So when you try to figure out what's the biggest number you can divide by, and then you kind of just look at it, and the easiest way is to say x2, x3, what's the smallest one? x2. So I'm going to divide both of these by x2. Y squared, y cubed, what's the smallest one? Y squared, so I divide it by y squared. That's kind of the easy way to do it. Lastly, okay, we're going to divide by a negative, because there's a negative in the front. They can all be divided by 10, so I'll do that. This is an x and an x squared. The smallest between them is an x, so I can take out an x. Y squared and y squared, they're both y squared, so I can take those out. Z squared and no z, and so there has to be at least a z in both of them for me to do this, which I can't. So I can't take out a z. So I divide a negative 10xy squared out right here. So negative 10 divided by negative 10 is 1. X and x, those can cancel. Y squared, that can cancel. And I'm just left with a z squared. And then negative 40 over 10 is negative 4. X squared and x, I can take out an x, or I'm left with an x, because 2 over there, 1 there. That would cancel. And y squared, those would both cancel. So this is now considered factored. So there's no fact, we haven't yet done what the title says, which is factoring trinomials, but we are common factoring right now, which will be useful when we do factor trinomials. So I'll do the next questions in the next video.